Welcome to Excel Business Statistical Analysis video number 17. Hey, in this video, we got to talk about logical tests for probability. Because if we're going to calculate probability, sometimes we're going to have to use an AND logical test, sometimes an OR logical test, sometimes even a NOT logical test. And we'll get to see the amazing and powerful functions COUNTIFS and filter. Now we're going to start out in the PDF notes on page 8. And our first task is to look at Venn diagrams and define a few important terms. Now a Venn diagram, that's a diagram to show the relationship between different events and the sample space for the experiment. The rectangle, that's this part right here, represents the sample space, all the sample points possible. The circle, that's this right here, that equals the event, and that can contain one or more sample points. Now, if we consider the event black hair, here's black hair, here's the full sample space, and this is a single condition logical test. That means we're looking for black within the hair color column. So as we look through, false, true, true, false, true, and the rest are false. So with 3 trues for the event black, we get a count of 3. If we have the event brown hair, we look through true, false, false, true, false, false, true, true, and the rest are false. So with 4 trues for the event brown hair, we get a count of 4. Now if we look at the event not brown hair, here's the event brown hair, but what we're interested in is everything else in the sample space. Now we can also refer to this as the complement rule. And that is, given an event A, the complement of A contains all sample points that are not A. So if we look through this data set, we ask the question, is that not brown? Well, that's a false. Is black not brown? That's a true. So for the full column, we get a false at the top, true, true, false, true, true, 2 falses, and 2 trues. With 6 trues, the event not brown hair gets a count of 6. Now, both of these logical tests involve a single condition. Now we want to consider 3 different events where there are 2 conditions. Here's the event brown hair or black hair. Here's another event, brown hair or hazel eye. Here's a third event, brown hair and hazel eyes. Now, both of these events are different situations when we run an OR logical test. This one we're running an AND logical test. Now, when you run an OR logical test for 2 events, that's called a union of 2 events. That is, the union of A and B is the event that contains all sample points that belong to A or B or both. Looking at the event brown hair or hazel eyes, here's event A, brown hair. Here's event B, hazel eyes. But guess what? There's a both. That's the intersection or overlap. That's where a person has both brown hair and hazel eyes. And guess what? That's where we run an AND logical test. Brown hair and hazel eyes. Now, wait a second. I thought we were talking about an OR logical test. Well, we are. But when you're counting and you're running an OR logical test, you have to worry about the AND, the overlap, so you don't double count. And we'll see how to do that in just a moment. Now, officially, the definition for intersection of 2 events, it is the intersection of A and B is the event that contains sample points that belong to both A and B. Looking at the Venn diagram, there is overlap. The sample points in that section belong to both brown hair and hazel eyes. Now, once we understand an AND logical test or an intersection or overlap, then we can understand a union or an OR logical test. Now, in this case right here, the events have overlap. But look at the event brown hair or black hair. There is no overlap, no intersection. We don't need any and logical test. Now, when we have two events like this, they're called mutually exclusive events. And this means the two events have no sample points in common. There's no intersection, no overlap. Now that we've defined all of our terms, we can look at the and or logical test against the data set. Now, this first event, brown hair or black hair, guess what? It's only looking at a single column. And when you have an or logical test looking at a single column, you know you have mutually exclusive events. And how that logical test works is this. It's got to look at each record one at a time and run both logical tests. Now, for the first record, we ask, is brown hair equal to brown hair? True. Then we ask, is black hair equal to brown hair? False. So we get a true, false. For the second record, we ask, is brown hair equal to black? False. Is black hair equal to black? True. So here we get a false, true. Now for the last record, we ask, is brown equal to pink? False. Is black equal to pink? False. So we get two falses. With an or logical test on a single column, you are only going to get either one true or zero trues. Now, if we look at the full column for this logical test, we have 7 trues. So the count for brown hair or black hair is 7. Now, the situation is very different when you have events that are not mutually exclusive and you're running an or logical test. Because guess what? You're going to have to work across 2 different columns. So if we have the event brown hair or hazel eyes, and we have to look through this data set, well, starting at record number 1, we say, hey, is brown hair equal to brown hair? True. Then we jump over to the second column and ask, are hazel eyes equal to hazel eyes? True. So we get 2 trues. And that works for an or logical test. We count this record. Remember, it's A or B or both. This is the both situation. For record number 2, we ask, is brown equal to black? And we get a false. Then we ask, is hazel equal to blue? We get a false. In this case, we get 2 falses. So this record is not included. For the 7th record, we ask, is brown equal to brown? True. Then we ask, is eye color hazel equal to eye color brown? False. In this case, we get a true, false. And remember, for an or logical test, all you need is 1 or more trues. So this record is included. If we look at the full column for the event brown hair or hazel eyes, there are 4 trues, so we get a count of 4. Now for the event brown hair and hazel eyes, we're running an and logical test. And all logical tests must be true for the and logical test to evaluate to true. That means from the list of possibilities when you run an and logical test for 2 events, it's only the first one, true, true, that gives you a true. It doesn't matter if one of the tests come out true. Those equate to false. And of course, false, false, that's a false. Looking at our data set for the and logical test, we only have 3 records where we get 2 trues. So the count for brown hair and hazel eyes is 3. Now, if you scroll down in the PDF notes, page 9 shows you the formulas we're going to create for counting. Page 10 shows you the formulas we're going to create for filtering data sets to get the actual sample points. Page 11 has notes about the filter function and the COUNTIFS function. And page 12 has a bunch of notes about the logical tests. All right, let's jump over to Excel. All right, we're on the sheet V17. Let's scroll down. And we're going to start out by looking at the logical tests used for filtering sample points. And we get to use the amazing filter array function. Now, here's our data set. So the first thing we need to know is how many rows there are in this table. So I'm using the rows function. And by the way, rows, that would give me 10. This would give me 10. The rows function doesn't care how many columns there are. It's just counting from 54 to 63 and figuring out how many rows there are. So there's 10 records. Now we'll start off with the event brown hair, and we'll do a single condition logical test. Equals filter. The first argument contains the array which you want to filter. We're just going to filter this one column, comma. And for include, we need to put an array of trues and falses that's exactly the same number of rows as whatever we put in array. So we highlight the hair column, and then we ask the question using a comparative operator. Are any of you equal to brown? Now I want to click on the include screen tip to highlight it, because I want to hit the F9 key and see what this evaluates to. When I hit F9, there's that array of trues and falses. Now it knows which rows to keep. I want to keep this one. I don't want this one. I don't want this one, and so on. Now Control Z, because we don't want to leave that hard-coded in. And very importantly, when we're making a direct array operation like this, we just place the comparative operator right next to whatever the array is and whatever the condition is. That'll be different when we get over to the COUNTIFS function. I'm going to close parentheses and hit Enter. There's the sample points. If I change this to pink, I better get 1. By the way, if you type the wrong answer there, instead of a calc error, F2, there's actually a third argument, comma. You can put whatever you want here. But if you want a word, you got to put it in double quotes. So I'm going to put something like NA for not available. So now it says not available. We'll keep this as brown. Now the filter array function, if you look up in the formula bar, is an array function. So the result spilled in anything below the top cell is grayed out. That's why if you want to edit, you always come to the top cell. Now let's hit F2. And we want to notice something about the include argument. We only had a single condition. So we had one operation, just are you equal to. But down here, we're going to have two conditions on one column. And down here, we're going to have two conditions on two different columns. And when you have two conditions, how we construct what goes into include depends on if it's an OR logical test or an AND logical test. For an OR logical test, we use addition, the plus operator, between the two arrays of trues and falses. For an AND logical test, we have to use multiplication, the times operator, between the two arrays of trues and falses. You'll also notice in your textbook the addition law of probability, an OR logical test, that uses addition. The multiplication law of probability, that's an AND logical test, and it uses multiplication. Now we'll do our OR logical test on two mutually exclusive conditions. In the top cell equals filter. The array, we want to filter the hair column, comma, and in include, we have two tests, one for each condition, and we have to put each logical test in parentheses. So for the first one, we say, hey, hair column, are you equal to brown? Then we close it off, use the plus operator, then open parentheses, repeat the hair column. And for this logical test, we say, hey, are you equal to black? Now I'm going to close parentheses. And there's our OR logical test in the include argument. And we'll come back in just a moment. But let's see if this works. Close parentheses and enter. There it is. I get all 7 items from this column that are brown or black. Now let's click in the top cell and hit F2 and see the magic of how this formula is working. Now in include, I want to manually highlight the first logical array operation and hit F9. Those are all the true falses for brown. Then let's do the same thing carefully. F9. Those are all the true falses for black. And the way the plus operator works when we're doing an OR logical test is we add the corresponding trues and falses. And when you add true to false, you get 1. And that 1 means 1 true. When I add false to true, well, that gives me 1. If I add the second to last false to the second to last false here, I get 0. Now let's highlight everything and include and hit the F9 key. The 1s mean it found 1 true. The 0s mean it found 0 trues. Now you might be asking, well, wait a second. I thought filter needed trues and falses. Well, in Excel, 0 is interpreted as false, and any non-zero number is interpreted as true. So all the 1s will be true, 0s will be false. Now I'm going to click the Escape key because I do not want to hard code that in. When I click Escape, it reverts back to the formula before I put it in edit mode. Now let's do our OR logical test on 2 different columns. Our goal is to get the sample points for brown hair or hazel eyes. So we use the filter function, and in array, let's scroll up. I'm going to highlight both columns because we want the complete record from both columns when both conditions match. Comma, and include open parentheses. Now we get the first hair column, and we ask, are you equal to brown hair? Close parentheses plus open parentheses. Now we go get the eye color column, and we ask, are you equal to hazel? Close parentheses. And here, there's a bunch of true falses in that first array for brown, a bunch of trues and falses in that second array for hazel. But if I highlight the whole thing and hit F9, now I can see I get 2s, 0s, and 1s. That 2 means it found brown hair and hazel eyes. The 0 means it found neither. And the 1, well, from this array, we're not quite sure which one it is, but it only found one of them. But because this is an OR logical test, 1 or 2 trues will trigger filter to get the record. Now, I only used the F9 key 1 time, so Control-Z, come to the end, close parentheses, and when I hit Enter, that is beautiful. I've extracted the records, the sample points for brown hair or hazel eyes. And sure enough, down here, I can see it got brown hair, but not hazel eyes. Now, here's the amazing thing about an OR logical test. Inside of filter, we can use the exact same construction whether or not it's 2 events that are not mutually exclusive or 2 events that are mutually exclusive. In either case, we put the logical test in parentheses and use a plus. Now we want to scroll down. And here we want an AND logical test, brown hair and hazel eyes. So from this data set, this is the only one that we don't want. Now I'm going to cheat. I'm going to come up here and F2, and I'm going to copy this even though it will not work for our AND logical test. Control-C, escape down here. So F2, and I'm going to Control-V. Now, why are we using this OR logical test filter? Well, because both this AND logical test and this OR logical test are using the same columns and the same conditions, brown hair and hazel eyes. So guess what? The only thing I have to change is the math operator. Not a plus, that's for OR. We're using multiplication. That's for an AND logical test. Now, the difference is this. If you get a true here and a true here, we're definitely not going to get 2. That's what you get when there's an OR logical test and 2 trues. Here, when you multiply true times true, it's just like multiplying 1 times 1. So the result is 1. When I click Include and F9, all we're going to get for an AND logical test is either 1, which means true, or 0, which means false. Control-Z, and when I hit Enter, there are the matching records or sample points for the logical test, brown hair and hazel eyes. Now, this is how to use the filter function to extract records. Now we want to scroll up and learn how to count. Now we have the same data set, and we need to count the records or sample points. So I'm going to use the rows function. We have 10 records. And our first task is to do a single condition logical test and check how many records there are where the hair is brown. And we get to use the amazing function COUNTIFS. By the way, don't use COUNTIF. That's a very limited function. COUNTIFS is easier to use and allows you to do a lot more. Now, for a single condition logical test, we only use the first two arguments. Criteria range 1. That's the range of values that has all the items you want to potentially count. Then I type a comma. It just says criteria. It doesn't say criteria range, just criteria. So that's where we put our condition. Now, we don't need to put a comparative operator here because COUNTIFS knows if we just put a thing, whether it's text or a number, it'll just count how many of those there are. Now I close parentheses, and that's our formula. I get a count of 4. Now we can calculate the probability for the event brown. Equals, well, there's the numerator, the count of brown, and there's all the items in the sample space. So we get 0.4. Now sometimes you want to do a not logical test. We want to count all the records that are not brown hair. Well, we can use the COUNTIFS function. Criteria range, we put in the same column of hair color, comma. And I cannot just click brown because then it would count brown. I need to put a comparative operator for not. Before that, G21. Now, COUNTIFS requires something unique amongst all the functions in Excel. When we put a comparative operator next to a condition or criteria, we have to put it in double quotes. And the comparative operator for not is the symbol less than, then greater than, and double quote. Now, I know that seems weird the first time you see it, but Excel understands that that means not. And we have to join it to the cell reference. So anytime you have a comparative operator, except for the equal sign, if you want to join it to a particular item in a cell, that's the construction. Comparative operator in double quotes, join symbol, and the cell. Now I close parentheses and enter. So I get a count of 6. Now the probability of the event not brown equals, well, there's the numerator, there's the denominator. Now if you already have the probability for the event, in our case, the event brown, then you can use the complement rule. And the complement rule comes from the fact that the total sample space is 100% or just the number 1. So if we know this probability for brown hair, we just take 1 minus that, and it gives us everything else. So the complement rule equals 1 minus whatever the probability for brown is, and enter. Now if I come up and change the single condition to pink, when I hit enter, I get a count of 1, a probability of 0.1. Not pink is a count of 9. And the two formulas for calculating the probability of not pink, 0.9. Control Z. Now let's scroll down and look at the OR and logical tests. And we're going to start first with the AND logical test. Remember, if we're looking brown hair and hazel eyes, we're interested in the overlap. That's where we get 2 trues, or the sample points belong to both. So in this cell, we're going to count using COUNTIFS. And because we have 2 conditions, we're going to use 4 arguments. Criteria range 1. I'm going to choose one of the columns. It doesn't matter which one I do first, but I pick the hair column, comma. The criteria must be for hair. Now I type a comma. Criteria range 2. That's the second column. And it has to be the same dimension as the first one. Type comma. Criteria 2. That's hazel eyes. Now, anytime you use COUNTIFS with more than one criteria range and criteria, you're doing an AND logical test. COUNTIFS is built to do this. So when I hit enter, I get a count of 3. Now when we do OR logical tests, it's not so easy. And for a mutually exclusive event and not mutually exclusive events, I'm going to show you 2 formulas for each. And I think the filter version is easier. Now for this first event, brown hair or black hair, we're going to use the same filter function we used just a moment ago. There's our formula checking the hair column, and include has our OR logical test, checking for brown or black. Now, as is, if I hit enter, it's going to spill the results. But what do I want? I want to count rows. So in the top cell, you just build whatever filter you want with whatever conditions. Put it inside the rows function because we're counting rows. And when I hit enter, I get a count of 7. Similarly, down here, we use the exact same filter formula we built just a moment ago. This one checks both columns. And for include, we're checking for brown hair or for hazel eyes. This one also, if I hit enter, would spill the 4 records. But we don't want that. We just want to build the filter formula and then put it inside of rows. And when I hit enter, I get a count of 4. Now let's look at the COUNTIFs. COUNTIFs, we're looking through hair color, comma, brown. When I enter, I get a count of 4 browns. Now, because the events are mutually exclusive, we can just add a COUNTIFs that will count black. For this criteria, we'll put in the condition black. Now, that's the formula. And for a mutually exclusive event, you might choose this because it might be easier to you than this rows filter formula. But this one formula works for both types of OR logical tests. Now let's see the complicated formula when you're doing an OR logical test and there is overlap. These events are not mutually exclusive. And the idea behind the formula is you count everything that's brown, then everything that's hazel, then you have to subtract the AND logical test using both conditions. And in the textbook, the addition law of probability is exactly that. But here we're going to do it with COUNTIFs. So we're counting brown hair. Then you add counting hazel eyes. If I enter this, it's double counting. That little intersection right there, because we have 2 COUNTIFs, it counted 1 brown and 1 hazel. But that's 2, and we really want 1, F2. So we have to subtract the overlap, and we have to repeat our AND logical test. And so that formula is more complicated, and it requires, if you're going to use COUNTIFs, to remember these 2 different formulas. But I get the correct answer. Now you can choose to use the rows and filter or the COUNTIFs. There are even other alternatives when you're running an OR logical test. But the advantage of the filter function in the long run is there are lots of other uses for the filter function. All right, that's it for this video. In this video, we talked about logical tests, filtering data sets, and counting. We talked about a single condition logical test, a not logical test, mutually exclusive OR logical test, events that are not mutually exclusive, running an OR logical test, and an AND logical test. All right, next video, we'll talk in detail about the addition law of probability. All right, we'll see you next video.